We have been enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. In this process, we have looked at several schemes to encrypt and decrypt the messages using substitution cipher, and all of that is great practice in logic, in slicing, in programming in general. Now, in this video, we look at yet another scheme which is called the RAIL FENCE CIPHER. We look at this in detail as to how do we encode this. First, let's try to understand what this scheme means. Now, the name rail fence cipher comes with this, a visualization that let's say we have multiple rails. So, for example, in this case, 3 rails. The idea is that we take the string that you want to encode and write it one letter per rail. For example, Python is cool, so I write PYTHON space is and so on and so forth. Now I write it like on let's say one letter per rail. So there are 3 rails in this. Now I read them back, let's say first row, second row, third row. Now this is very interesting because notice what has happened is that I've got, for example, POSOYHNI something O, and so on, and then finally T space C space. Now this is really different from what we have done previously, because notice here we are getting letters at a spacing of 4. Here we are getting letters at a spacing of 2. Now we can take one more example. Let's say the same string with say 4 rails. Now again, like I said, 4 rails. So I imagine that rail number 0, 1, 2, 3. So I write PYTHON, a blank here, IS, blank here, COOL, and I add a few more blanks. So we'll talk about this later, right? Now I read this row by row. So basically I go and read, for example, this, then this, then this, and then this, right? So for the same, message string, we have got a different coded string, and that's expected because it changed the number of rails, right? So we will see how to do this because this is really an interesting exercise. Now basically the steps that we are going to follow at a broad level are, we are going to find out if we need to extend the message length. So what is the message length that we need given, let's say, number of rails? So we take n as the number of rails, and we determine if we need to extend the message. Next, we will create slices for every row. Now this step is somewhat involved because, like I just indicated, every row has a little bit of a different logic, right? But there's a pattern that follows. We'll make use of that. And finally, we'll put all these slices together, basically row by row. And this is much like the other schemes, right? That's what we do. We take chunks of pieces and then we put them all together. Now, I must say before I start this is a bit involved, but extremely interesting. The logic that we follow, if you think about it, it's really interesting. And let's get on with it. Now, let's first think about this problem, right? We want to be able to compute the right length of the message that we can encode. Now, basically, the idea is that I want to create, let's say, what I call complete units. Now, I define one unit as n characters written downwards and then n minus 2 characters written upwards. Now, this may sound a little bit magical, but I'll show you, and I'll urge you to convince yourself. I'll show you some examples. Basically, what I'm trying to get at is that I must have my length of the message as a multiple of n plus n minus 2, or in other words 2 times n minus 1. Let's see this with examples because that makes it really clear. Let's say my n was 3. Now I talk of one rail, or say one unit here, as let's say this particular half v, truncated v, because I'm ignoring this. Notice this is forming for me 4 units, and the reason I see it this way is because this kind of completes the like brings me back to the first rail. So how is it n plus, let's say how is it basically n plus say n minus 2? Well, because I do n rows this way, so 1 2 3 and 1 which is n minus 2. So essentially I'm doing 3 plus 1 which is 4, which is also same as 2 times n minus 2, which is 2 times 3 minus 2, right? Now let's take one more example. N equals to 4, so I write 4 letters this way. I must come back 2 letters up with, so that once I do this, then I'm back on the original rail. What that means is that my basic unit here is 6, and I can obtain that by doing 2 times 4 minus 2, which is exactly what I had, right? So I hope this is clear. You can actually take more examples to convince yourself, but the point is that if I'm able to extend my message to this length, then I would always create nice complete units of this sort, right? And that's the whole idea. This is important because later on we'll need some of these strings to have a specific length. Having done this, right, now let's just think about the first row. This is not too hard actually, because what's going on really is that if I look at, let's say, n equals to 3, what's happening really is, like I said, I'm writing n minus 1 letters downwards, one more letter, which is n minus 2 in this case, upwards. in which case I'm in basically, in other words, I'm writing, say, three letters here, three letters here, which means that starting from the zeroth, character on my message, I am taking every fourth character, and that becomes my first row. Now, obviously, when I'm writing this in, as a code in Python, this whole thing is just a visualization. We are just going to use slicing. So, like I said, for the first row, the string that I'm extracting from the original message is basically, in this case, zero, ending all the way to the end, and step of four. Okay. What happens, let's say, in the case of, let's say, n equals to 4 rails. So here what's happening is I write three letters downwards, I write two letters upwards, which means there are five letters in between, and between all these elements there are five letters, so 3 and 2 and so on and so forth, which means that I am, for the first row, picking up, let's say, 0, so we are going, starting from 0, going in steps of 6, and going all the way to the end. Like I said, this visualization is helpful, but ultimately this has all to go in the code, and that's what we're trying to do here, which means that what I'm trying to get at, and again, convince yourself that this is all correct. So there are exactly n minus 1 plus n minus 2 characters in between two characters, and that's because n minus 1 this way and n minus 2 that way, regardless of what the n is, which means that there are 2n minus 3 characters in between, and hence we'll slice as 2n minus 2. Now again, take some numbers here. If, let's say, n is 3, I'll start at 0, slice with a step of 4, n is 4, slice with a step of 6, and so on and so forth. Now once again, spend some time thinking about it, and convince yourself that this is indeed correct. Now coming to the last row, right? In fact, we can see this visually. The last row is pretty much like the first row because it's just inverted from the first row. So if I look at, let's say, the characters on my last row, the gap between them is exactly the same as the gap between the characters on the first row. So basically, last row is, has got 1, 2, 3, 4, 5 characters in between, just like 1, 2, 3, 4, 5 here. So essentially, last row is actually almost exactly the same as the first row, and you can see that in n equals to 3 as well. The only difference is that my starting has to happen from, for example, letter number 2 in this case, so 0, 1, 2. In this case, letter number 3. So really, first row and last row can be handled quite similarly because all I'm doing is to create two different slices at a certain spacing, which is in this case, let's say, 2n minus 2. Only difference is my start changes. So for example, if my n was equal to 3, start will become 2, but slicing step remains 4. N is equal to 4, start becomes 3. N equals to 5, start becomes 4. Now, once again, remember that the visual representation is useful, but eventually it all goes in the code. So we must have a way to translate that. And that's exactly what I'm doing. So here is this thing a little bit more visually. Like I said, on the last row, it's like exactly the same as the first row in terms of spacing. Only the initial letter changes. Coming to the middle rows, the situation is a little bit more involved because you notice that the spacing between characters is not uniform. And let me just tell you this, from a diagram because more clear. Let's look at the case of n equals to 4. Notice I am getting here in between these two letters, there are 3, in between here's 1. There's 3, there is 1, which means that this regular slicing won't work. And that becomes a problem. It's not so obvious in n equals to 3, but you just try n equals to 5, n equals to 6, you'll realize that there's really two different spacings that come up between alternate letters, and hence something has to be done. However, and this is where a very smart trick comes in. Notice if I view this as, let's say, two different slices, which means that if I look at, let's say, y, I, L and nothing after that, and N, O, and let's say this as two different slices, then I'm looking at exactly a gap of 6 between this, between, say, for example, this and this, as well as the next slice. Now, what I'm trying to get at is that even though the spacing between characters is non-uniform in these middle rows, in fact, I can view this in two steps. I can do two slices. First slice, which, for example, goes from letters, in this case, letter 1, with a step of 6 all the way to the end. Next slicing, which goes from, for example, 0, 1, 2, 3, 4, 5. From letter 5, again, steps of 6. And then I can sort of interleave them just like I did in the even odd swap. So I take one letter from here, one letter from the other slice, one letter from the first slice, one letter from the second slice, and so on and so forth. In fact, the same thing applies on every row. Again, convince yourself, don't rush through this. Convince yourself this is all correct. But what I'm trying to say is that, if you notice carefully, then there are really two slices that are going on, which have been mixed with each other. For example, in row number 1, the slice 1, again, has a step size of 2n minus 2, which, like I said, is common. However, it starts at 1, The next slice starts at, let's say, n plus n minus 3. Now, again, this may look like a bit of a mystery to you, but you don't have to see it that way, because remember, it's n minus 1 this way and n minus 2 that way. So basically, I've got n minus 1, minus 1 character with me here, right? So essentially, I've got, so if I see, for example, if I see this, it's n, so basically the start is n plus n minus 3, because that many characters have happened before, which is say 2n minus 3. This start is 2n minus 4. Now again, please convince yourself this is all, reasonable to you. In general, okay, in general, if I'm looking at row number k, basically my step size is still 10 n minus 2. Start for the first slice is at letter k, which is for example 0, 1, 2, 3. Start for the second slice is, n plus n minus 2 minus k, and this is really happening because I'm taking sort of kth letters before this. Right now, again, spend some time convincing yourself. But with all this done, right, with all this done, in fact, we are ready to put our code together. Notice what we are going to do is that first I'm going to define m is 2n plus 2n minus 2. If length of message is not a multiple of m, I go and append that many spaces, and thereafter I just do a loop between range of n, which is, remember, the number of rails. First, kk represents the row number, so I go, for example, if 0 or 1, then my message is really a sliced version starting from kk. Notice if kk is 0, then the message starts on 0, which is the first row, which is basically like, starting from 0 here or starting from 0 here. On the other hand, if my kk is equal to n minus 1, the last row, then I'm starting again from kk, which is n minus 1. So it makes a lot of sense, because, for example, here it will start from 2. This slice will start from, for example, 3, right? Now, having done this, I then look at my intermediate rows. Again, I'm creating two slices. First slice starts from, kk. Second slide starts from m minus kk. Now again, convince yourself, and I'm going in, spacing of m again. And once I do these two slices, I just put these two together. Notice temp1 and temp2, temp1, temp2, because this jj runs in a loop. So it kind of interleaves these two, just kind of like our even odd swap, right? And once I do this, then I have my message ready. Let's see, all this working in the code, because that's when it gets sort of alive, comes alive. So I'll just take you back to your code. Now here I'm going to, define, let's say, def, say, rail fence, say, cipher. The cipher. Again, I take inputs as, say, let's say I just call it, say, message, MESSAG, and n, which n is the number of rails. Now, first thing first, I define m is, say, 2 times, n minus 2, because m is the sort of the basic unit that I have. And I just decide if my message needs to be, let's say, updated, sort of like appended with some string. So I just say if length message, modulo, let's say, m is not equal to 0. Now, in this case, if that is the case, then I'm going to have to append some, say, message is equal to message, say, message plus, let's say, m minus len. Again, we have done this before, so I just say message, message by, so modulo, say, m, and I'll just do this many spaces, right? I think this should be clear. We have done this many times. I add this many spaces to my message. Now I start creating my coded message. So I say it's an empty string s, which is what I'm going to return later on. Like I said, I'm going to run a loop for every row. So I say for kk in range n. Remember, there are n rails. So for every rail, I'm going to run this kk. Kk is row number, or say rail number. I'm going to just create a string called temp, because these are my slices from the original string. I'm just going to look at first the, say, the 0th string. So if I just go and say if kk is equal to, say, 0, we'll just do this much first, and we'll have it printed out. So if kk is equal to 0, I just look at temp is equal to, say, message, message, again, I start slicing from kk in till all the way to the end in steps of m, right? So this is my kk equals to 0. Remember, the same formula is going to apply for kk equals to n minus 1. So I just go and put this kk is equal to, for example, n minus 1, right? Because the last row has exactly the same formula as we saw. If this doesn't happen, then that means I'm in one of the middle rows. I have to create two slices. So I just go and create, for example, temp1 is one of my slices. So that is given by message, say, kk all the way to say m. And remember, kk is increasing, right? So when kk comes to, say, for example, 1, which is my middle row, then this message, this slice happens from 1 all the way to the m. And I create, say, temp2, which is given by message, message, say, m minus kk all the way to the end. Now again, please convince yourself. Don't try to take it as a it's sort of like the face value, but convince yourself with different m's, different k's, rather different number of rails, a different case, that this is indeed correct. And once this is done, then I'm going to sort of interleave these two, so which means mix these two around. So again, all this has to happen inside the else. So I just say, for example, for, say, jj is another variable now, in range, let's say, length of, say, temp1, right? If for jj in range length of temp1, I'm going to just say temp is equal to temp plus, say, temp1 jj plus, say, temp2 jj. Now again, these are strings, so plus is going to act like join apple banana. And with this done, basically I would have created my temp for every k, and all I need to do is to keep appending my s to this temp, right? So keep appending temp to my s rather. And with this done, in fact, I can return, I can go and return my, say, return s. For the sake of our understanding, we are going to print this temp for, let's say, different uses, right? So what I'll do is that I'll just run my code. I'm going to call this function. Let's use a message of, let's say, our x is of course a little bit longer, but let's use just, let's say we do rail, say, fence rail fence say cipher, rail fence cipher, say Python is cool. So this is the same message that I had with the illustrations with. Let's say I do this with, say, 3 rails, right? So if I did this, notice what happened, right? I went through this loop, kk equals to 0, my n was 3. My n was 3, which means that my kk went from 0 to 3, 0, 1, 2. When kk was 0, my temp was poso. That's because it is basically just a slice, 0, steps of 4, and another 4, right? So I got POSNO. My next message, next time the KK got printed, was basically interleaving of these two, and that's because I took, let's say, string starting on Y, and I took a string starting on, let's say, H, and I sort of mingle them up together. Finally, I get a TNC. That's because the last row is also a slice that starts on row number 3. Now, just for sake of sort of making sure everything is correct, if I just go back to my example here on the on the description that I first started with, this is exactly what I'm getting, right? So POSO, that's because making sense, right? So I'm going steps of 4 here, 4 because it's again 2 times n minus 2, and this is exactly what I get. Let's just take one more example. Let's say the same rail fence cipher I did with, say, steps of 3. I get slightly different string, of course, but we can verify this, that this is indeed what I expected. Basically, I wrote this in sort of like a let's say this rail fences. I'm going to get a P space O, Y, N, and so on and so forth. That is exactly what I've got. I hope you found this interesting. This is quite involved, but really very logical. Go through it slowly, and I'll be happy to discuss this. In general, if you find that this way of learning excites you, gets you thinking, look at our website and you will find that there are many, many, many such activities that you can refer to. Take care, enjoy programming. Thank you so much.